Hello and welcome to 10Y Science Lesson for the 4th of January 2021. Well done for getting here, so let's make a start. Our learning objective today then, we're going to be comparing the practical methods of demonstrating conduction and convection. To do that, we're going to first describe how heat is transferred through metals via conduction. We're going to then explain how the rate of conduction in metals is modelled using a conduction ring. We're then going to describe how heat is transferred through fluids via convection. And then finally, we're going to describe observations seen when modelling convection in a convection ring. Now, a bit of key info here. Your submission will be pictures of the work. Okay, so you need, after this, if you write on paper, if you're doing it on your computer, obviously you can upload that work. But I want you, please, to be taking a picture and then uploading it to Teams as your evidence that you have completed this work. And don't worry if I'm going too quick, okay? You can pause, you can rewind the video to learn at your own pace. If you want to go back and watch a video twice or watch a certain bit twice, that is absolutely fine, okay? So main thing though, learning objective to compare the practical methods of demonstrating conduction and convection. Let's make a start then on conduction first. So conduction takes place in solids. And I've got a diagram of a generic solid here now. So when I'm thinking of solids, think of the table you're leaning on to write. Metal, the pen which is in your hand. Okay, that is a solid. And I've got some key points about a solid. First of all, you can see the particles are touching. They're very neatly arranged also in rows and columns. Think of now an exam hall, okay? They're in strict rows and strict columns. Now, the big thing that we need to know now is even in solids, they are slightly moving. They are vibrating, okay? Just buzzing, okay? They're not moving loads. They have to stay in that place, but they can move around a little bit. Now we're going to look at how heat is transferred via conduction then. And I've got a video here showing what happens to particles as they are heated. We're then going to go through that. I'm going to explain that to you and give you some real key points which you can look at that show you how conduction works. So I'm going to zoom in a little bit so we can see this video. And then I'm going to hit play. Now I'm about to turn on the Bunsen burner and I want you to notice this side where my lightsaber is now. I want you to notice that as those particles are being heated, they begin to vibrate more violently. Now what happens when they vibrate more violently is that they begin to bump into each other. And what I want you to think of, if something bumps into something, that's going to cause it to bump into it as well. So what's happened is that all of the particles here started vibrating more violently. As they did that, they bumped into each other, causing more particles down the line to vibrate. And when more particles are vibrating, we're seeing that transfer of energy. So, key points then. Point number one, when we heat solid particles near the heat source, begin to vibrate more violently. These particles that we've just heated bump into other particles, causing them also to vibrate. Now that is that transfer of energy. As they're vibrating, they're bumping into others, forcing that energy down my piece of metal. And finally, as time goes on, more particles in a solid continue to vibrate more, continuing the transfer of energy. So this just keeps going, okay? A bit like a domino effect. If you have a big line of dominoes, see these sometimes, they're quite cool. Got a big line of dominoes here. If I push this domino over, all of those dominoes are then going to fall, aren't they? So it's like a bit of a domino effect. So that's conduction theory. We're now going to look at, well, how could we show that in metals? Well, we do it using something called a conduction ring. And I've got a conduction ring here. Now, when you're back in school, I'll be able to show you this experiment. But for now, I'm going to talk you through everything that's going on. Now, let's just go through some equipment then. I've got a Bunsen burner by here. I've got a conduction ring. Now, a conduction ring is kind of like a bit of a cross. Okay, and I've got 4 metal rods, and each of those metals is different. So I want you to think I could have an iron rod, a copper rod, a brass rod, an aluminium rod. As long as they are 4 different metals, that is fine. Now on the end of those rods, I'm going to take a paper clip, just like any paper clip that we would use in school. Okay, so literally just a small piece of metal, and I'm going to stick that on the end with petroleum jelly. Petroleum jelly is also known as Vaseline. Okay, so Vaseline, petroleum jelly, and I've stuck a paper clip on the end. These are my paper clips. I know it's not the best drawing, but those are my paper clips. Now, what I'm going to do is, when I've set this equipment up, I'm then going to place my Bunsen burner, as shown in this picture, directly underneath my conduction ring, right in the centre. So what I want you to notice is that I've got an equal distance. Now what's going to happen is, obviously, if I put fire underneath a metal, that's going to get hot. And eventually what is going to happen is it is going to melt my Vaseline, and my paper clip will fall off. So we're seeing how fast does it heat up. If it heats up really quickly, my paper clip is going to fall quickly. So we've got some variables here. The thing which I'm going to change, my independent variable, is the type of metal. Remember, we got 4 types. And then going my dependent variable, the thing I'm measuring, is the time taken for the paper clip to fall, measured with a stopwatch. Okay, so I'm not just going to do that in my head. I'm not going to count up. Okay, I'm going to use an accurate stopwatch here. Control variables, well, I've got to make sure I've got the same paper clip. Got to make sure it's the same size. It's not fair if one is massive and one is little. I've got to keep the same brand of jelly. Okay, remember, I want that jelly to be melting at the same temperature, because I'm looking at how fast does my metal heat up. And I've also got to make sure I've got the distance from the paper clip to the heat source the same. Think, if I put my flame, this flame I'm about to draw out, there, colour that in yellow so you know that's a flame. If I put that there, that paper clip is going to get hot much quicker than that one. So I need to make sure I've got the same distance between each one. Now, we've got a prediction here, just to make you aware of this, and this is the key thing you need to get your head around with this practical. This is the key point. The better the heat conducting properties of a metal, the shorter the time taken for the paper clip to fall. Now, this key thing here, the better the heat conducting properties, that is it's a scientific way. I've gone for that top answer there of saying the better it heats up, or the faster it heats up. Okay? Now, just one thing that we could get wrong here, okay, and I've done this and I got it wrong myself. You can miss when the paper clip falls, okay? You could mistime that. So that's our inaccuracy. You could miss the exact time when the paper clip falls. Now, if you need to rewind and rewatch that little slide, that's fine. But we're going to move on and do some questions. So what I'd like you to do, please, at this point, is press pause on your video and have a go at answering these 6 questions. And then going to go through the answers later. So press pause. So our conduction answers then. Question 1, what type of material does conduction take place in? That is solids. Question 2, what happens to particles as they are heated? Well, they vibrate more vigorously. Question 3, how does conduction transfer through an object? Particles vibrate and bump into each other. That's our key points then. Name the equipment used to model conduction in metals. That is a conduction ring. In the conduction ring experiment, the better the conductor, the shorter the time it takes for the paper clip to fall. Remember, if it's a better conductor, it's going to heat up quicker. And then question 6, state the source of inaccuracy in the conduction experiment. We can miss the exact time when the paper clip falls. So make sure you've got those answers. You've ticked them off if you've got them right, or you've corrected them. Obviously, if you've got a red pen as well, just like we would in class, we should be corrected in red pen. So we've done conduction. We've shown how it can be modelled. We're now going to look at convection. Now, first thing we need to know is convection takes place in fluids. And our two types of fluids are liquids and gases. Now, we don't need to know the exact sort of structure. We don't need to be able to sort of recall this. What we do need to know, though, is why are they called a fluid? And the key point in both a liquid and a gas is that the particles are able to move. Okay, we can see that a liquid and a gas don't look exactly the same, because a liquid they're touching and a gas they're not. But our key thing in their similarity is that they both have particles that can move. And this is really important for convection. Now, in fluids, heat is transferred through convection currents. Now, I'm about to put this video on and I'm going to talk you through a convection current. And then I'm going to give you the key points. Really important now with focus, because these are points which could be 2, maybe 3, and if they put it in a QWC, could even be 6 marks in your exam. So I'm really focused now on these key points. Now, just before we start, we can see we've got a room here. I've got a heater where my radiator is. And I've got some arrows showing me a convection current. I want you to notice here, I've got my fluid. In this case, I've got a gas, but I've got my fluid here. And whatever I say now is the same if we were looking at a liquid, for example, water. So first thing, my particles are going to be heated as they go to the radiator, and they are going to rise. And our little bit of knowledge here then is the warmer gas is less dense, so it rises to the ceiling. So that's my first thing, is if we heat a gas up, or heat a fluid up, sorry, it becomes less dense and will rise. And I'm going to play this on. As I move away from my radiator, I cool. Look, my gas is beginning to lose heat to its surroundings. Losing heat is cooling. If you lose heat, you cool. And it becomes more dense. As it becomes more dense then, it sinks or falls towards the floor. Okay, so my cool gas is sinking. This repeats then. Watch, if I play this on again, as my particles move towards the radiator, they absorb heat energy. In other words, they're getting heated. I know then from my last go round that as it's heated, it becomes less dense, so it's going to rise. I then know as I move away from my heat source, I'm going to lose heat and cool. And as I cool, I'm going to become more dense and sink to the floor. So, key points then, which you need to know. If you want, now it might be a good diagram to draw, is just show this convection current. Okay, show that as you get close to a radiator, it rises. Show as you get to the cooler area of the room, it falls. Okay, you might want to go back through and start annotating this diagram. Add your own notes. But the key points here are hot air becomes less dense and rises. Okay, so if I heat something up, it's going to rise. As it cools, it becomes more dense. We saw that as it was moving away from the radiator at the ceiling. My cold air becomes more dense and sinks, and then that process is repeated to form a convection current. The only way I can stop that current is if I turn the radiator off. Now, demonstrating convection. Now, just like conduction, we use a conduction ring. Convection, we're going to use a convection ring. Now, this is another experiment I'll be able to show you when we get back to school. But I've got a diagram of this convection ring. So the first thing I'm going to do is I'm going to fill it with water and then I'm going to heat it. Now what I want you to remember then is if I'm heating water, it's a fluid, that means the hot water is going to rise, which is indicated by this red arrow, hot rising, and my cold water, which is far away from the heat source, is going to cool. Now, we want to be able to see convection happening. We don't want to just trust it because we can't really see see-through water moving, can we? So we add a purple dye. We add potassium permanganate to show the convection current. And what you are going to see, and we've got 2 key points here. So let's label at this point as point A for a beginning. At point A, I'm going to see my purple dye rising. And the reason for that is because my water is becoming heated and it is becoming less dense. Now what's going to happen is that purple dye is going to rise. It's then going to follow the shape of the tube. Now we know that as I'm going that way, I'm getting further from my flame. So I must be getting a bit cooler. So I'm going to begin to cool, and that's finally, I'm going to become my coldest at point B. Now at point B, we are going to see the potassium dye, the purple dye, flowing downwards. Okay? And the reason for that is that my particles become more dense as they cool. So they're going to sink. And this is going to be repeated. So I'm going to see my purple dye moving round in that continuous convection current. Our last thing for this lesson today then is to answer some questions on convection. So again, I'd like you please to press pause now, have a go at them, and then we'll go through the answers together. Okay, question number 1 then. Convection takes place in fluids. What 2 states are fluids? Well, we know that a liquid and a gas count because they both have particles that can move. Finish these sentences. A, as a fluid is heated, it rises. B, as a fluid is heated, its density decreases. C, particles in a fluid fall when they cool. Heat is transferred to fluids via convection currents. Question 3, name the purple chemical placed in a convection ring. That is potassium permanganate. Picture's just cut off the final 2 letters. And then state and explain what is happening, what will be seen at point A and B in the convection ring. So we've got our convection ring here. So we've got A, the particles rise, and I've said that because I'm next to my Bunsen burner, and that is because density is decreasing during heating. Oh, I've spelled density wrong there. Let's just get that right. Density. Made a mistake. And at point B, I said that the particles fall, and this is because density increases during cooling. Make sure you've got them in there. Now, well done for attending the first science online lesson. Make sure now that you've taken pictures of everything. Make sure it goes on Teams so we can see that you've done it. Okay, and well done. Hope you have a good rest of the day and look forward to seeing your work. Bye-bye.